Building a flagship space telescope takes 2 decades of engineering, thousands of scientists, and up to $17 billion of public funding. You don't spend that kind of time or money to build a general-purpose camera. You build it to interrogate the cosmos in a highly specific way. Every flagship observatory in NASA's history is ultimately a highly specialized machine, engineered from the ground up to answer a single, specific question about our place in the universe. In the 1990s, the Hubble Space Telescope was launched to answer a foundational question: what does the deep universe actually look like? The James Webb Space Telescope looked further back, searching the infrared spectrum to ask how the first stars and galaxies formed. Later this decade, the Roman Space Telescope will scan wide swaths of the sky to measure how the universe is evolving on the largest possible scales. But none of those machines are equipped to answer what might be humanity's oldest question: are we alone? That task requires a completely new machine. NASA calls it the Habitable Worlds Observatory. For 30 years, our greatest telescopes have been built to show us the universe. HWO is being built to find out if anyone else is looking back. The primary mission of this new observatory is to locate and directly image 25 potentially habitable, Earth-like planets orbiting Sun-like stars in our galactic neighborhood. To understand how difficult this is, consider the math. An Earth-like exoplanet reflecting light in the habitable zone is roughly 10 billion times fainter than its host star. Finding a planet in that glare requires a coronagraph, an internal physical mask within the telescope designed to block the blinding light of the central star. But for a coronagraph to work at a 10 billion to 1 contrast ratio, the telescope's optics must be physically locked in place. If the mirrors shift by even a single picometer, a fraction of the width of an atom, the starlight will leak past the mask. Even with near-perfect stability, stray photons will still leak through as optical noise. Engineers will have to run the incoming data through advanced post-processing algorithms to strip away these residual speckles of starlight until the hidden planet is revealed. At this scale, finding a habitable world is no longer a challenge of raw mirror size. Success depends entirely on the precision of light suppression and data extraction. Building a machine with these tolerances carries enormous risk. The James Webb Space Telescope proved this when complex engineering hurdles caused years of delays and pushed its budget over $10 billion. To prevent a repeat of that overrun, NASA has issued a strict mandate for HWO. Every piece of critical technology must be fully matured, tested, and proven before physical construction of the telescope even begins.